All right, welcome everyone. My name is Jordi Atamuson. I'm currently in my fourth year studying applied geophysics at Federal University of Technology, Akure, and I'm also currently serving as the president of the Society of Exploration Geophysicists, FUTA. I would like to welcome you all to the second session of the Geoscience Experimental Workshop. I hope that you have already downloaded the software and already gone through the geology materials that have been sent to the WhatsApp group. So today we have G2 introduction. Frank Blau has been a business intelligence data architect for 15 years and has over 25 years of technical experience in relational and dimensional database technologies. He is currently a principal data architect at Epcon Pro Consult in Art, Austria. He has been a developer, architect, analyst, and educator in a variety of vertical markets and technologies. His research includes 500 in the use and implementation of data warehouse architectures on structured data, metadata management, and analytic presentation. Frank is a 2018 and 2020 IBM champion for cloud and blockchain and was a 2014 IBM champion for information management. He continues to provide thought leadership and research in such diverse areas as streaming data, blockchain, modern data architecture, and cloud computing. Frank is also a public speaker and author on topics related to business intelligence, disruptive technologies, and mobile computing, software methodologies, and is also a member of the Digitali Initiative in Dublin, Austria. Thank you for joining us, Frank Bao. You have the mic.
Thank you so much for that wonderful introduction. Sometimes when people read my bio, I'm like, wow, who is this person? He sounds fabulous. I wish I could hire him. um, so I was invited today to speak to you a little bit about data architecture, and maybe if I can get through my introduction pretty quickly, I can take some questions about how it might apply to some of the things that you guys are working on. But I would encourage you also to use the chat if you want to. I'll leave that open on my screen here. If there's a particular question or you can't hear my audio or something like that. So, so I'm just I, I'm going to assume that you're all pretty smart people and you understand a little bit about what the concept of data is, but I'm not going to assume that you understand databases per se. So we're going to kind of start with a little bit of an introduction to how databases are structured and what I believe is the future of database architecture, not just for my career, but also for yours, particularly in scientific fields. This is a very, very interesting technology. So, if that's all well and good, I'm going to start my presentation here. And this, just for reference, this was part of a larger presentation that I did as a TED Talk recently. And I'm sure that we can share around all that contact information also. Um, and I will just put my email address down in before I forget to do that, actually, so you can all find me. I'm on LinkedIn. I'm on everything. I'm easy to find. So, okay, I'm going to share my presentation here. Hold on a second. Let me go full screen here. Can you all see that?
Yes, sir. Yes, sir. We can see it, sir.
Excellent.
Yes, we can see it.
Super. So this is Marshall McLuhan. He was a kind of a what they call a communications theorist back in the 50s and 60s, and he coined this expression that the medium is the message. And he was mostly talking about radio and television, but what he meant by it was sometimes the structure of your data is more important than the content. Now, you can't do without content, obviously, but how you structure your data tells a story. And so that's kind of where I got the idea for this presentation, is taking that idea and applying it to database architecture. So let me just go to my slides here. So traditionally, when we store data in a database, we put information into tables. And I'm sorry if this is a little bit rudimentary for most people who understand something about data, but we put data into these tables and we relate them to each other. So I may have a table of customers, I may have a table of products, I may have a table of locations. And if you've ever worked on a big database, say like what we call an ERP system or something like that, you can literally have thousands and thousands of tables. I've worked on some very, very large databases in my time, and most of them had many, many, many tables on this relational side. So this is what we call a relational database. And we do this so that we can execute transactions really quickly. Like when you buy something from Amazon.com, for example, you don't have to wait 5 minutes for the database. It happens right away. And the reason is we've broken everything down into little tiny tables of information that we can update very, very quickly. That's kind of enough to understand sort of how a relational world works. But you can see already from here it has a structure. That is, I have tables. I connect the tables to each other. I allow the tables to reference each other. And so this model we call a relational database. And these are great. They work really well. But once they get really, really large, if any of you have ever done this before, they get very hard to work with because you have to know, for example, how do I connect the person table to the phone number table, to the purchase table, to all the other tables that I might have in my database. So this is why it's really important to have to understand the underlying architecture of it. And that's what makes relational databases so reliable too, is that they have this, they're very tightly patterned, or that we call that a schema. That is, if there's a person in the database, every person in the database shares the same attributes. They have a name, a first name, a last name, a phone number, an address, all that kind of stuff. You can't have one person with one schema and one person with another. And that's good for transactional purposes, but it limits your flexibility in the future as you go forward. Hi, Ruth. Ruth invited me here, so
Go
we're
on.
just we're just getting started. It's cool. So, but once we started building out these relational databases with hundreds and hundreds of tables in them, people started asking more complex questions, like what we call analytic questions, like how many things did I sell to the people who looked like came from this community and that were this color of shirt or something like that on this day of the week. Those kinds of questions are very hard to ask of a relational database. You can do it, it's not impossible, but it gets very cumbersome, very large, very quickly, and hard to do. So what we invented, and I was around when this happened, is the idea of what we call a star schema. And this is also, you might also hear this referred to as a dimensional database, where you have the things that you did in the middle there, like the transactions, and then all the attributes of that transaction are just around it in a star. Like you may have a table for product, a table for customer, a table for the purchasing date. And you can see from this is much more of a business perspective of the kind of questions I'm asking of my data. But again, let's go back. The medium is the message, right? And what's so cool about this is we actually redesigned the model. We moved the data from the transactional model to the dimensional model in order to ask different kinds of questions. For example, in the transactional model, we want to know what happened. But in the dimensional model, a dimensional model, we may actually want to know more detailed information about both when something happened and who it happened to and what some attributes of it were. It's much more about a business or even a marketing perspective of a problem solving or some sort of business problem you're trying to solve. And this is great. We did these for a long time. This is how I spent most of my career, is working in this. You'll also hear this referred to as business intelligence, right? This is a very popular field right now. If you know how to do this kind of work, you will be employed forever. Trust me, it's very lucrative work to be able to do. But the problem is that people also need to use not just information to look up analytics, but they need information about an application. So let's say I write like a mobile application or something like that, and people want to access data in my database. Well, both this model and the other one aren't very good at that, right? Because I may have information, for example, about customers all over the place. I may have some information in phone logs. I may have some information in my relational database. I may have some information in my data warehouse, in my business intelligence system. And so what we came up with is a different kind of model. And I skipped one. I'm gonna go back. This is called a document model, okay, where we actually store all the information about a customer, for example, in a document. And this document model is very powerful for applications, right? Because applications can now say, oh, I need to know everything about a customer. I don't care where it came from. And you can store information in these document databases. And this is very, very powerful because in document databases, I don't care about the schema. Remember how I told you in the relational models, every person has to have the same schema. Well, in a document model, I can just extend the schema as I learn new things about customers. Let's say some of my customers went on a trip. Not all of them, just some of them. I can actually add that trip information just to some of my customers that went on that trip. And I don't have to worry about making all the other customers have a blank trip field, a blank trip information, basically. It allows us to do this sort of you'll hear this referred to as no SQL also, which actually means not only SQL. But what this means is I can ask questions without having to worry about the structure. It's a very, very powerful way. And now I'm going to go back to the one that I skipped, which is this is a different kind of information. If you think, I imagine some of you, given what you do, might deal with data coming from machines, data coming from sensors, for example, temperature or pressure, or I'm a big weather junkie. If I could point my screen around here, you see there's like a weather station there, there's a weather station over there. I have like weather stations and all stuff all over my deck here. And this information comes in very, very fast. If you look at the example down here, I may have 5 sensors, but I have information literally coming in every 1,000th of a second here. And we need to be able to store and visualize this information in real time in order for it to be useful. So we came up with a different kind of database, and we call that a time series database. One very popular one is called Elasticsearch. And if your information is coming at you this fast and it's all about when something happened, this is why you want to use this kind of database. But again, if we go back to the medium is the message, we've told some different stories. We've told a story about tell me everything about a customer, regardless of where it came from. That was one kind of model. The medium is the message. This particular model you're looking at now is a time series database. That tells you when something happened, and that is a different kind of story. Again, we've changed the structure of our data to tell a different story. Any questions so far before I go on to the next interesting thing? If I don't hear any questions, I'll just keep on plugging away here. I think you can raise your hand if you have a question too. I'm not sure I will see all of them, but I'll just keep going if I don't see any. And you can type your questions into the chat window too. That makes it easier for me too to answer them.
Yes, you can type your question to the chat, okay?
Yeah, that's the easiest thing. So this next kind of data is kind of where I think I want to spend the rest of my life. They're called graph databases. And what a graph database does is it organizes information into what we call nodes and relationships. For example, Frank Blau, that's me, was born in a relationship and has a subject, an object, Santa Barbara, California, which is a place, right? Or Frank Blau lives in Dornbirn, Austria. TEDx 2022 takes place in Dornbirn, Austria. And you notice you don't need to know anything about this data. You don't need to know anything about the structure, anything to know what story is being told here. Right? We're telling a story here about relationships. And this is very different because if you go back to our first model where we had the relational database where we were relating the two tables to each other, I didn't know anything about that relationship. I just knew that products are related to people. I know nothing about that relationship. But with a graph database, I actually can come up with really complicated things about the relationship, like Frank Blau lives in Dornbirn, but Frank Blau is friends with Ruth, for example, on LinkedIn. And Ruth is friends with, I'm going to name somebody out here. I'm just going to go down the list. Is friends with Sammy on LinkedIn, and Sammy is friends with Anuha. I hope I pronounced her names correctly, right? And you can see you can build these very, very complicated relationships in a graph database that are very, very difficult to do actually in relational databases. So the story we tell here becomes one of the not only do the things have relationships, but the relationships themselves have data associated with them. For example, I could say Frank Blau lives in Dornbirn, but this relationship lives in could have some attributes too, like how long have I lived there? What kind of apartment do I live in? Do I live with someone? Or TEDx takes place in Dornbirn. What time does it take place? This ability to have information about your relationships is something that graph databases do really, really well. What I'm kind of fond of saying is that whereas a normal database tells you what you know or when you know something, um, in some cases, but a graph database can tell you how you know it. And if you think about managing customer relationships, for example, just knowing that you know someone is not enough to have a marketing relationship with that person. But if you know how you know that person, I know Ruth because we met in Frankfurt. I know Ruth because we're on LinkedIn and we share a common interest in this. I know so and so because of X, Y, and Z, right? These kinds of more complex relationships are really easy to do in graph databases. And I can add new things in there. I could say Dornbirn, Austria has population of 60,000, something like that. Dornbirn, Austria has average climate temperature of 25 degrees or something like that. And once I have that information in there, I can start running queries about it. I can say, show me all the people born in places that have similar climates but also did a TEDx talk. I know that would be a weird question to ask, but you could do that, right? These kinds of queries kind of fall out of a graph database. So you can imagine you can build out millions of these things. If you're interested in this, there's something called DBpedia, which I'm sure all of you, because you're students, are familiar with Wikipedia. Wikipedia is a great source of content about a huge, huge number of topics. In fact, I think just about anything. And what DBpedia is, it's broken down all of the facts inside of Wikipedia into these what we call triples. Frank Blau, born in Santa Barbara, California. So anything that's in Wikipedia can be queried in this form also. And so what this means is you can use all that information for free. You don't have to pay for it. DBpedia is free. And there are literally hundreds of thousands of free data sets in this format, what we call RDF triples. Triple meaning basically Frank Blau, born in Santa Barbara. That's what we call that combination of things, a triple. But if you start doing this, eventually you're going to want to build your own database, right? You're going to want to store this somewhere. So how do you store this information? Well, we store this in something called a graph database that looks kind of like this. Once you start digging into the data, you'll want to say, let's put all the people who went to school in California over here in green, and then let's put their friends over here in blue, and then you can say, hey, how does this person know this person over here? Right? You can run these kind of very deep relationship queries very, very simply. This is not something that requires a degree in computer science to understand. But again, we've taken our questions. We have questions about relationships, and we need a model that supports that. We've modified our model to support the kinds of questions that we're asking. This is the most important thing to take away from this, is that as you interact with the data in your careers, and I really don't have any idea what that data is that you guys interact with. I'm guessing it's geospatial information, for example. It may be GPS data, for example. It may be soil data, maybe other things, other attributes of data. Again, I'm not quite sure what you guys all do, and maybe you can, if you have a specific question, I can explain to you how it might fit into this context. But anything, for example, let's say you're looking at animals or something like that, a particular species or a particular yeah, let's think of a particular species. You can already see how this model works really well for talking about a species, because you would have what we call a taxonomy. That is, this is a member of this class, this is a member of this species, which is a member of this class, which is a member of this phylum, if I get my words correctly, and all that links together here into these very complicated graph databases that you could ask really cool questions of. And so you don't really have to go back and understand all this relational database stuff in order to take advantage of graph databases. So, but what's next, right? This is what's really interesting to me. If you think about a typical business doesn't have just one of these. They may have some CRM data in a graph, right? Customer relationship management data in a graph. They may have a data warehouse with a star schema. They may have a transactional system that they run their business, like an e-commerce system or something like that, that your business is run on. And they may have information about their servers, running in this time series data, and they may have applications using document interfaces. This is what we call a multi-model platform. And this is the future of databases, is understanding which of these models fits into the context that I'm thinking about right now, but also how do I need to get these things to work together. And it gets a little technical, and I'm happy to answer questions about that, but I thought once you've seen sort of this multi-model platform, it's going to open up your minds to thinking, wow, I don't just have one model in my life or in my business. I actually have multiple models. And so if you're going to model, if you have a multi-model life or a multi-model business, you should also have a multi-model platform. The good news is there's tons of open source code for this. There's tons of enterprise software for this. This is not hard stuff to find how to play with, and it all talks to each other very, very easily through mostly through API interfaces. So it's not a hard thing to put together if you're the person who's plumbing all the stuff together. So that is where my career is right now. I'm actually going up to Hanover next week to give a couple lectures and to participate in some panels talking about just this very idea of multi-model databases. But it all comes back to this idea that the medium, that is the structure of your data, is very, very important to the messages that you're trying to tell. So that's the end of sort of my lecture part of this, but I'd love to take some questions from you. And I already have one already from John here. What software can I use to build a sales funnel? So by sales funnel, you're saying, how did my customer get here? I'm assuming. Like how did I find this customer, and how are my what are my customers doing to come to me, basically, right? So if you had a graph database, and again, I'll go back to that as my example, you could make a node for every part of your website. And you could say, when someone visits this node, give them a point. And if they stay on the page for a certain amount of time, maybe give them some more points. And from that, you can actually build a map of where they were on your page. And the nice thing about graph databases, they're really good at recognizing patterns. So I can say, let's say I have 5 different pages to go to, and people go, most people go A, B, E, just from 1 to 5. A, B, E is a very typical pattern for people buying things. You could think of this on Amazon. I go to the home page, I go to search, I find the thing, I buy, right? A, B, E, I'm done, right? But let's say I see someone come in and they do A, B, C, E. They do something different, right? Well, all I have to do is track where they were on my website as a node in my graph database. And again, I don't need to redesign my database if I add new pages. It's just another node in my database. And I can build out complicated patterns. But more than just a sales funnel at this point, I can also say who else looks like that, right? Who else is doing A, B, C, E? Let's say it turns out that people from Austria all do ABCE, but people from Nigeria do ABDE, and people from America just go ABE or something like that. All of this is all of these patterns is, you could say, show me all the people that look like this pattern also. And this is a very good use of a graph database. More questions?
Thank you so much, Frank.
Yeah.
Thank you so much.
Oh,
Do we still have any questions? You said, okay, yeah.
I have one more here. It says, can you recommend an online course that can help build my skill in this area? So I'm a big fan of Udemy. I'm sure some of you know it already, Udemy. I will type it in here if you don't know it. And they have tons of courses on this. And if you just look up Udemy's, and if you look up Tiger Graph, which is my favorite graph database, let's see there, udemy.com, Tiger Graph, yeah, Tiger Graph, and you can play with Tiger Graph for free. You can go to their website. They'll give you a free account. I think you can have like 50 gigabytes of data, and they have some kits pre-built for different topics, and you can play around with loading data into it from like CSV files and things like that. If you do get more into that and you have some more specific questions, feel free to reach out to me to help you with it too. I'm more than happy to do that. I really enjoy helping people get to learn how to do this kind of stuff.
Thank you so much. Thank you so much. I wish I think we can just maybe clap for him in the chat.
Yeah, you can clap for me. I don't know. No, clap for you guys for being curious about it, really. And thank you, Ruth, for tracking me down and inviting me too.
Yes, that was a very nice one. Thank you so much. Okay, I think you please can drop your LinkedIn profile to them. I can drop it for them so they can maybe connect with you.
Yeah, let me just pop over to my LinkedIn thing here really quick. Hold on, let me just do that.
Yeah, thank you.
Let me just stop my share here. Let's see here. Me. New profile. Okay. There you go. That's my LinkedIn profile.
Please, can you plug this?
Yep. And like I said, if you have specific questions around a particular problem that you're trying to solve with your data, do reach out to me. I can save you lots of time and point you towards some resources for that. I'm not really sure what kind of data you are working with there. I see someone who's obviously doing some sales data, but I don't know what's going on there. Yeah, but if there's anything that I can answer for you about data, like I said, feel free to reach out to me. Even back into like relational databases and document databases and time series and all that kind of stuff, more than happy to help out there too. So
I have a question and a bit of a comment, and that is, do you think how long do you think predictions and graph is going to last? Because this is,
you want me to put on my crystal ball hat here?
The peak of digitalization.
Yeah. Well, what's interesting about
so how long do you think it's going to last, or do you think maybe
something else is going to come along? I mean,
yeah,
it's possible. Yeah. The interesting thing about graph is that if you research the history of it, the mathematics associated with graph databases, for example, a cryptocurrency, blockchain, all runs on graph databases, but the math behind it has existed for hundreds of years. It actually was a very popular problem in mathematics in the 1800s. Is how can you get from one island to another with crossing the least number of bridges or something like that? That's actually a graph database problem. And there's a whole field of mathematics around this, which is way outside my realm. But I think that graph is going to be around a long time because of its power to understand relationships, which is really what software is about right now. And also because of how easy it is to use. I mean, it is super, super easy to write graph code. Um,
Yeah.
and it's not esoteric like relational databases can get very esoteric, and people like
Yes.
people like me understand them, but it's hard to explain to other people what you're doing in there. Document databases are somewhere in the middle. They're if you can know how to read sort of file formats and stuff like that, they're pretty easy too. Time series solves a particular kind of problem, and they're also really cool. I use it all the time. If anybody ever wants to see like how to do weather data, for example, I have tons of examples, and I can share code with you and things like that. Did someone have another question there?
Nine, nine, nine.
Yeah.
Okay, that's nice. Thank you
Yeah,
so
so I
much.
think it's going to
Thank
be
you so
around.
much.
I think put it this way, I'm staking my career on it right now. I'm actually everything I do, I'm putting into doing graph data project, and so I think it's, I mean, I'm old, I'm 58, but I definitely feel like this is a good place to be in a career, and there's lots of work in this space right now. And I'm
Yes.
happy to talk to anyone who wants to about that. If anybody ever wants to move to Austria and work in data. So,
Thank you, Frank. Thank
yeah,
you.
my pleasure.
Okay. Yes.
So,
I will share my screen now. So
okay, thank you so much. And do you want me to stick around, or are you going back to your agenda now?
yeah, I'll go back to our geoscience.
Okay, thank you so much, everybody.
That was my story. Yes, that was my
Yeah,
story.
okay.
Thank you. See
Reach out
you.
to me anytime, people, if you want to talk. Okay, thank you. Ciao.
Okay.
Nice to
And
see you, Ruth.
ciao.
Take care.
Thank
Ciao.
you. Bye. Ciao. Wow, that was amazing. I don't know who else is excited about this intro, but I am excited and I'm happy I was able to learn one or two. So can you see my screen?
Yes, ma'am.
Okay.
We can see.
Yes. Thank you.
Yes, we can see it.
So I know everyone is ready. Were you able to get your set log ready and the new plots? I need responses, please. Thank you.
Yeah, we are ready.
Good. So I think there is no need for me introducing Frank. Frank is a very exciting person and he has a lot to share, and I'm happy he's selfless. So like what he said, the future is graph, although we have different type of feeds. Some of them can be leaked, scripts are very easy. I also went to this a software that we use to show graphs, which is GNuPlot. And also the set log is not a graph, but it's also a kind of a graphic representation of something. So that's why I was happy that Frank agreed to come and talk to you guys about the importance of graph and what graph can actually do for you. So it's like the easiest way to communicate your expression when it comes to your database. That is what the graph is doing for us. So Frank is a whole lot. I think I've shared his video and his TED talk, and I'm happy he did justice to what I actually have in mind. So before we start, I just want to take this little quote. I was able to get this year, and it's interesting that we are talking about graph now. And one thing I know IT does for you, one thing I know technicality does for you is that you are the one creating it, you are the one coding it, so it makes you actually feel like a god. So the first quote said, "Notwithstanding, therefore, that we have not witnessed a large continent, yet as we may predict the future occurrence of such catastrophe, we are the earth coming Messiah." So if we can be able to predict the future of anything that is coming, that is what a prophet is. That is what the Messiah we are looking for is. So as a geoscientist, I am the coming Messiah. So I am the Jesus that they have been waiting for, because I can predict what will happen next. So the next quote said that only geoscientists are authorized to regard an old man as part of the present, other than the nature, as they are predators. So remember the law of uniformitarianism. I think you answered that question. The next one said, a geoscientist can be boastful because nature itself is bragging. If not, why is climate changing? So I think all this quote is just trying to stir your mind on you can do it. Because if you can't tell your mindset that you can do this, there is possibility that after I finish teaching, you can carry this set log and put in under your table, and you never practice. And once you don't practice it, like science. And I came to tell the world to sleep. I can tell the world to sleep at any day I wish and call it a tsunami day. So I can wake up tomorrow and tell everybody in Ubomoro that there's going to be a hurricane, everybody will be at home. So I'm a superhero. So this is just what the course is doing for you. It's trying to stir your mind to know that you already have everything it takes for you to understand this. This is not too much technical, just like what Frank said. Graphing is simple compared to other coding that you can ever think of. So, and also what my supervisor said day before yesterday when we did our first section, she said that one of the benefits of Nuplot is that one is accessible, is free, and anybody can understand it. So whether you are very good with coding, because most people will tell me, I'm not good, I don't have a background in C++, I don't have a background in this, and I don't have a background. You don't need to have all those things. It is something that you just have to understand the sequence and follow through. So that is it. So the next slide says what you need to know. So you need to know, first of all, that geoscientists are interested in predicting and understanding the physical way the Earth works. So because we need to predict, we need to understand. That is why we work with time series. That is why we work with so much of the past. That's why we do reconstruction, because we need to know what is going to happen in the next day. We need to know what is going to happen. Our prediction, steering mind, is what makes us the superhero, just like I said in my quotes. So next thing is that plotting data and sketching the relationship among variables helps us to understand and predict the behavior of the different situations. In case you're asking yourself, what is this plotting data all about? This is just the answer to it. And we need to simplify it to make it easy to understand, because Earth is really complicated. So the best way for you to express what you actually want to talk about in terms of relating Earth, especially like a course like us, where one particular thing is going to link up to so many things, so is through graphing. That is why my supervisor said yesterday there is no geoscience anywhere without a model. And that is the fact. The graph can also be a visual way of predicting or forecasting geoscience events. So today, the first thing I'm going to teach you is how to get a data. There is a place to get a free data, and it's called Pangea. So I'm going to lead you through opening your Pangea, opening an account, possibly within 5 minutes. You can download the data that we are going to work with. So you aren't expecting me to give you data. You're going to get your data by yourself. Any type of data, maybe you are doing a project, and maybe your project is you're working on environmental, you're working on paleontology, you're working on any field of geology. There is a data available linking to such. So even if you don't have your data, the one you have to maybe get from the university or get from your supervisor, you can start practicing how to use these data with the data you can get from Pangea, and it's totally free and accessible for everybody. So the next thing is that graphs are a way of making scores of data points manageable and often more understanding. All the whole thing we are going to talk today is just trying to communicate what you have known, what you have felt, what you have seen in the field, what you have understand in the field in a way professionals can understand it. I want you to understand something. When you want to go to the industry, people that bid for the oil firm, for the business or the oil whatever, most of them are not geoscientists. They are business strategists, right? So you as a geoscientist come in maybe as a consultant to work with these people. You have to make your words or your project very easy for them to understand, because they cannot come and start telling them a kata formation and a bada formation. They probably will not understand that. So, but in a graphic way, anybody can easily understand that, oh, this one is going up, because it's visual. Understand? this one is going up and this one is going down. So maybe this is a trending and this is dipping. I think everybody here is most of us here are uses crypto. We understand when it's dipping and when it's not dipping. So next thing is the 8 basic plots is Geoscience use. I don't want to go through all these things, but this is it. You will talk about the genesis plot, talk about the emergence plot, the metamorphic plot, destructive plot, convergent plot, divergent plot, oscillating plot. All these things are the kind of plots we mingle with, kind of things we had to work with. When you're talking about your regression and your transgression in terms of the position environment, you're probably talking about a destructive plot. I'm talking about a convergent plot. So I can share this slide to you later after this work, but first let's get to the business. I hope your system is available and you're connected to internet, because we are going to the Pangea website now. Thank you. So quickly click on your Google. As you're seeing me doing it, be doing it too. And I'm going to go to my web. I'm going to go to my web. And I'll click here. Can you see it? Hello, can you see what I'm doing? Hello?
No, we can't. It's only your power translation.
Only my, okay, let me share this.
Yeah, you need to share your screen.
Yeah, okay, thank you.
I don't have money to buy second-hand slippers.
So can you see my web now?
Yeah.
Can you? Yeah, okay then. So you just quickly type Pangea. You see this one? The data publisher for Earth and Environmental Sciences. Just click on it. So for this particular workshop, we are going to do new plots, and for me, I'm going to work with a stratigraphic data. You can also decide to work with any type of data. Just like I said, they have different type of data. You're already seeing different topics of geoscience topics that is here. So we are going to download this data. And even if, as we are doing, we possibly not use the data we are using, you're free to use any data. It's the same.
Yeah,
the same.
We can
Hello.
get it.
Hello. Okay, good. So you can download any data of your choice, or you can also download this one I'm downloading. So let's type biostratigraphy. So this is a whole lot of biostratigraphy data. So this is a whole lot. So I will just quickly, I want to download the data from this person, and you can see download, right? So I'll click on my download and it's downloading. So good. So I just have it here. I can open file. Yes, this is data. These are the data sets. So I can open this now. Yeah. I think you are seeing what I'm doing, right? So have you been able to open in your own, please? Can I hear a yes?
No.
No. You're too fast,
Why?
please.
I'm too fast. Okay. So are you able to download the data? Not yet.
Yes.
Have you been able to download the data?
Yes.
Yes. Okay. Can you open your data?
I'm trying to extract it out of the zip folder.
Okay.
I've expected
Someone says isn't showing download. So I think you can just now open your data. Yeah. Can you see what I'm doing? Hello, can you see my data?
Please, can you just give us like a minute to sort out our stuff before we resume for the class?
Okay, but I want to know if you are seeing my what I'm doing first.
Yes, we are seeing it.
Okay, good.
Just a minute.
If it's not showing download, click on the Howard stuff. Then when it opens the paper, you will see download and scroll a bit.
Stephanie, have you been able to download now? Amoduni, have you been able to download? I think this is pretty easy to download. Okay, yes. Okay. So I should go ahead, right? Is a yes. Okay. So now I have my data in this form. So this is a biostratigraphic data. You can see the top, the depth. You can see for the top, the bottom, and everything. So I'll just quickly copy this data here.
And what you are seeing is not being projected. It's not displaying.
This is not displaying.
Yes, it's your browser that is displaying right now.
Yeah, we are still seeing the download on our page.
I think you should just share the screen itself rather than sharing the window.
To get this thing. Can you hear me? Please, can you go back a bit, please?
Yes, I'll go back. I'm coming.
Yeah, maybe just start from the.
I think you share again, right?
Yeah, just start something.
Yes,
Yeah.
share your screen again, then share entire screen. So you can see everything again.
Because we are lost like this. I'm trying to.
Please, don't worry, I'll find you.
I try to get the site and everything is.
Can you see my screen now?
Yes, we can. We can see your browser.
Okay, good. So I think we'll be able to go anywhere now. Yeah, can you see this place?
Yes, we can.
Yes.
Yeah, so this is the data we just downloaded. I just opened the data. Have you been able to open data from your end?
I just opened it.
Good. So when you open it, you're going to see so many things, the depth. You have to copy out all this data and put it in an Excel file, Excel spreadsheet. So just copy, then put in your Excel. So I'm pasting it here. Do you see what I did? So we can quickly save this now as new plots dot data. Yeah. So I'm going back to my PowerPoint. So you have been able to download, get the data from Angier and everything. So this new plot we are going to treat now, we have different things. I will walk you through. First is how to do a simple plotting and editing, how to plot from a file, which is this data we'll have now. How can you put it in new plot and use it for your plotting? Then second, you have to do fitting of data sets. That is how to use your Pangia, which I just explained now. Then how to set a table and create data. Then how to do a polar plot, a parametric plot. Then second to the last is how to make histograph. So then and how to save your project to an image, because probably you want to save it for your thesis or anything. So that is it. So then after that, we are going to now talk about set log, and then we'll talk about the tips of some tips you are going to use to make your set log very easy, basic terms, and let's go back to our new plot. So if you have downloaded your new plot, I just want you to open it. I'm just opening my own now, and this is my new plot.
Oh, sorry, I didn't know that we were meant to use no plot. All I saw was set log.
How many people did not know that we are doing new plot today? Because I thought it was new plot I even introduced the last time too.
Yeah, you had the download for the set log.
It's all right, don't worry. Please continue. Please continue, don't worry.
Okay. So I'm opening the new plot, and this is it. So new plot is a graph program, like I introduced last time, that it works with system, but that doesn't mean you have to know C++ before you can be able to plot a graph with new plots. Why new plot is very interesting is because you can be able to tell new plot what you want your data to look like, how you want it to look like in a kind of a script way. So there's two ways to actually write a script in Uplot. One is that you can use your notepad to write a script and then import it in Uplot. Then the next other way is that you can also write the script directly to Uplot. So these two scenarios I'm going to show you as we proceed. So first of all, you have to know that the only plotting you can do in a new plot is two types of plots. Two types of plots you can do in a new plot is the one they call data data type and the CVS. I think Prince is having an issue logging in, sorry. So and the CSV type of data. This is the type of data you can plot with your new plot. So that means that only data you have to convert it to this type for you to be able to use the new plot. So first of all, as you already downloaded the data from the Pangia, it would be wise of us to make that data in CSV, what we can be able to use it. And there is a very quick way to do that. One, you can convert your Excel file directly to a CSV file, meaning that you can just go to this Excel that we have. This Excel that we have here. This, and just quickly go to save, do save as, and convert it. But one thing that you have to put in mind is that new plots, like I said, is for plotting of graph. So there are some things that is in that some things that is in our file. Some things in our file, like this particular silic fossil, so representing arrows, so that new plot does not care about it, because this now is not numerical. So new plot is not going to interpret it. Meaning the best thing for you to do for you to get a new plot data and match data for a C plus is okay. Someone has it up. Can you talk?
Good evening, ma.
Yeah.
Thank you so much. I'm one of the person that have an issue with the new plot map. Can you please quickly give us a kind of recap on how to download the new plot so that I can also follow you, ma? Thank you.
Okay, so let's go back to downloading of new plots.
Exactly.
Hope you people are not hungry, because I Google Boom today, because we are going to take a whole lot of time. I thought we are going to pass this level, but since we are going back, me and ready. So just quickly type new plots. It's very simple to download. New plots, let me type it full, so you not tell me what did I do. You see new plot homepage? Yes, you have seen it. Do you see where they have download? Yes, you are seeing it. So this is the latest version of new plots, the 5.4 type. So so what I'm looking for is the window one, because you have to get the one that is compatible to window before you can be able to download it. So I think we need to go to another site. Okay.
Yeah, go back to new plot download. That's it. Windows binary built by Tatsuro.
Oh, sorry. And we are here before.
Big social. Big social. Yes. Well.
Nine. I think there is an easier way to do this.
And I can drop an easier method in this chat. I'll drop the link.
Okay, if you have the link, please drop it in the chat for them.
Because we are not unable to download the.
There's no
How
way
many
again.
people have not been able to download?
We have other ones. Yeah.
I've dropped the link in the chat. So just click that link immediately. You see download. Click download and install it.
So Dara used first for I think we came across the first problem. Yeah, okay. This is not what I want. Please, have anybody used the link?
I've used the link and it's working fine for me. I've opened the Notebook app.
The people that is having issue with download, have you clicked the link? Have you been able to go to the site? I think if majority have downloaded, we should just move ahead.
Where is the link? I'm trying to download.
Okay,
Let's just give them like 3 or 5 minutes.
Okay, that is fair. That is fair enough.
Yeah, I've downloaded it now. I'm trying to run it in the system.
Okay, we are waiting for you.
Okay.
Well done. This lithology tab on this your Excel that is displaying, I can't see it in that data set that I downloaded. Please, where did
Which
you get
one?
it? The Excel sheet that is open right now that you have on your system.
The Excel
Yeah,
sheets.
before Excel. Or are you using that one for a different thing?
You mean this Excel sheet that I'm just showing now?
Yeah, before Excel. Book 4 Excel.
Now, this
Yes.
yeah, this is what I have on my system before. Look at the one we created, the new plot data.
Okay,
The other
okay.
one is what I have on my system before. Yeah.
Okay, just confirm. Yeah.
Okay.
I've been able to
Please,
download and
guys,
install.
if you've installed it,
Have you been able to install it?
I've
Yes, I
installed
have.
it.
Yeah, almost
That-
true. Almost true.
Almost. Okay. Idowu, please, what are you knowing? You said no. You have not been able to install yours too.
I'm true with installation.
Good. So we can continue, right?
Yeah, let's fetch that and let's go.
Okay. So this is new plots. Is everybody here?
That's what I'm doing on my screen right now.
Yes, I am.
Okay. So first of, like I said, we have tracks of what we want to do. First of all, I want to
Please mute your mic, guys.
Please, can you mute everyone? Please, can you mute everyone? Please. So first of all, we'll do simple plots and editing, then plots from a file, then plots from a folder from Pangea, which is what we just downloaded, how to get a table and create data, polar plots, and the rest. So let's go to the simple plotting and editing. So to your new plot, I think the simplest plotting we can do now is maybe to do a little arithmetic graph like sine x, cos x, and something like that. So before we start, I want you to get some terms in new plots. New plots use simple languages, meaning if you want to do label, is the same label, nothing else. If you want to do set, it's the same set. If you want to do plot, it's the same plot. And also, because of how smart it is, it's also want to make your life very easy, in the sense that you can, instead of writing width, you can write W and you understand that. Or instead of writing point, you can write P. So I'm going to show you all the ways you can do the whole thing. So let's use something like the sign. Let's start with the sine and cosine. So I can just say maybe set X label. Okay, next thing you need to remember is you have to make use of your spacebar. Your spacebar is very important. So, like if I leave it this way, nothing is gonna happen. So I have to always put
Sorry, I can't hear well. I don't know if everyone else is experiencing the same.
Yes, I think I was kicked out. Can you hear me now?
Okay,
Can you
yes,
hear
it's a
me?
lot
Yes.
better. Yes, it's a lot better.
Can you hear me?
Yes, we can hear you, ma.
Okay.
Yes.
Oh, sorry, I have to share again. So this was what I was doing. I was explaining, first of all, I explained the sets. Secondly, I explained the use of using your spacebar. Then I explained using your reference if you want to refer to something. So now I did something and they said unrecognized option. Just you can also always ask for help in uplot, but we can solve this. There is already an arrow indicating where we need our help, right? So I think we can use it to solve. We can do back.
I'm sorry, please come again. After typing set X label,
Yeah.
X, what do we do? Do we press enter?
Yes, yes. You just press enter.
I've pressed enter and just showed me next new plots again, like a duplicate of what I just typed.
Yes. Is it telling you this?
It's not telling me unrecognized. I think your spelling of label is wrong. LABL.
Okay.
Or should that how you should? Is that how it should be?
So it's another thing is that is what they call it, case conscious. So if I'm supposed to put capital letter and I don't put capital letter in what I'm writing, that means I'm wrong. If I'm supposed to put small letter and I don't put small letter in what I'm writing, that means I'm wrong. You get the point. So all these things are tricks that you have to understand when you are writing your script. So the correct spelling is what? L-U-E, this, yeah? And you have your X and you have your X. Then you can also set Y. Good. So now we have set X and Y. We can make this Y now to be our sign Y. I want to give you another tip. Now you already have this. So you can easily go back to this film, make a change. If you want to clear something, you just do Q, just type Q, then you have cleared. So that is, sorry, quitting. But if you want to clear is just exclamation mark and a clear, then it will clear whatever you write, the mistake you make, and you want to come back. So let's go back to the beginning. So we'll set X label to be
Your label spelling.
let me and this label the title to be X or maybe V. It's the same thing. Then we'll set our Y label to be sign X. Then close it. So next thing we'll do is and set it to I think we can even plot this. We can plot so we have something now. And you see you are seeing the X label to be the view. Is anyone following?
Look, how can we go back? Like if you make an error, like you want to clean something, erase something, how do you go back?
If you want to quit Matter and start from the beginning, just the way you have new plots now, just type Q and enter. It will quit, then you start again. But if you want to just clear something, what you just do is write just exclamation mark. I have to close this. Clear. I'm out of it again. So just let me, I think I'm making a mistake with declare something. Just quit and let's just start again. So I can just write plots sign. So this is where we ability want to put something in the x-axis and put something in the y-axis. So the easiest thing to do is to set the labels. So you do set your x label to be v, then you set your y label to be sine x. Okay. Sine is now. So now this is a sine graph, right? And this sine that is here, you may decide to maybe move it to your left side, or you may decide to even clear yourself. You may also decide to use another line, make your line thicker or make it bigger, or you can also decide to put a dot point. So all this is doable in the so this is what next thing I'm going to be showing you. Remember, this first stage is trying to plot, label, and do some other markings. So that is what we are going to be doing now. So for you to do that, you can decide to do so. I think the easiest way to open something, write set. So like if I want to clear this, I write on sets key. So now this onset key I write. Now if I do sine x,
Okay, one bar.
I'm sorry, I can't hear you properly. I think maybe you should
Is anyone
check your
confused?
video. Yes, yes, your audio has been breaking up. I think you should,
Can
if
you hear
possible, can you put up
me?
your, yes, but it's breaking.
No,
Can you
no.
put up your video so we can
Huh?
just hear your voice and see the screen? Is it possible you can switch off your video since that may be affecting the network? So just audio and your screen.
Can I pause my video? Okay.
Yeah, like your face enhanced.
Okay. Is it better now?
Yes, much better.
I can't hear anything again.
Yeah. Can you hear me now?
Yes, I can.
Good. But my screen is still being shared, right? I'm
Yes.
thinking I've even trying to connect back. I'm thinking I've lost you guys. So I should continue, or is there any? I'm seeing some questions.
You can continue. You can continue.
Yes, you can.
I don't know. I'm kind of this. Okay. Yes. I think then please the my co-host should please be responding to me so I'll know what to do, because I can maybe be talking and I don't know whether you are following what I'm doing or not.
See, when I
Okay.
type the first command plot sign X and I wanted to enter the next line, the thing just plotted automatically. I'm trying to go back to go to the next command down. Can you hear me?
You just press enter now. Enter will take you to the next.
Press enter, like dial plot sign X, the thing will just plot automatically, the graph will just come out.
Yes, a graph will just come out.
Then, but I want to enter that set X label V, but I'll just be seeing the graph. I should just close the graph and start afresh or something.
You can minimize the graph, and anything you are doing will be work like you'll be seeing it in the graph. You can even move your graph to maybe the left side of your system, and you'll be doing something. You can also be seeing the changes anytime you press enter.
All right. Thank you. Let me try it now. Because I was seeing something.
So we can further, right?
Yes, yes.
Now, next thing we are supposed to, now we have seen how to cos X. So simple thing you do, just plot sign X. When you want to do one or two things at the same time, the only thing you use to differentiate them is a comma code. So you just put comma and do cos X. So this is sign. Remember now, you see, remember you always have to put your space bar. Your space bar should always work, because if I didn't put the space bar, this is already an invalid command, so it's not going to work. So if I press my enter now, you are seeing two graphs, the sine X and the cos X here. So how are we going to edit this thing in case I want to change this sine X now to this, put a color, put a point, put all these things? How are we going to do it? So the best thing to do is you you see what I pressed? There is one arrow up here. So that arrow gives you the command you have done before. So you can come down and say sin x with, you can use sin x with, remember I said new plots are very flexible, meaning instead of you writing line points now, line points, can do with line points, maybe just or with line points and line color, maybe line color 7. So after this, I'm going to show you different types of line colors. I'm going to display it here so you see it. And they have numbers. So red is not like number 7, green is like number 8. So instead of you to write line color 8, red, you just write line color 7. You understand it. So with line color, and this person is having issue coming in, because first with also line points. So when you click on, okay. So new plot, you always where your mistake is coming from. So this is why I have a mistake here is because I did not put a space bar. So just quickly go to this arrow now to bring you back here. Then you can go to that place that you they have identified a mistake for you. Then you can fit it in 9. Okay. With line points. So in case you have any issue that maybe you don't want to stress yourself, you can easily come to this place and type help. But I'm still trying to know why it's not accepting the command. This is comma. Yes. So this is what I want to fix. Oh, okay. The issue is not even the comma. The issue is with the different changing. Remember, I said it is case sensitive. So I was using with as and I was busy using
Yeah, the audio is bad again. The audio is bad again.
Yeah. Let's minimize this again. Yeah. Button for you to navigate what you're doing.
Miss Ruth, please, your audio is a bit bad.
Sorry, man, your voice is breaking.
Now with line point, with point, you can
Miss
do.
Ruth, your audio is breaking.
Can you hear me now?
Yes.
Yeah, we can hear you now.
Yes, we can hear you now.
Okay. So what you are clear with where I am, right? And what I've been doing, right? Is it a yes?
No.
Are you
No.
able to do it in your end?
We are trying to follow up.
So where are you? So where are you stuck? Let me explain.
Please, can you do a recap on the last command?
This is your last line. Exactly.
Yes, last line.
Please, anyone talk? Do you know how to get back to where you are?
Yes.
I said you can use this arrow. If you look up here, you are seeing one arrow going this way and this one. You can use it to go to what you have done before and just modify that instead of you typing it again and again. And you can also use your arrow button, the up and the down, not the side one. So what I just did was I just used my up button to bring out this thing again. Remember before we go to this place, when I wrote line points, then comma this, it did not work. Reason was because here I have width as W, but here after my cost I have this as a full. And I said that new plot is case sensitive.
Sorry, we can't hear you clearly.
You don't not understand these two things. They are different.
I think our network is really bad.
This LP means line point. So I can also modify this because what we are, remember, see our graph here. Okay, so what we are trying to do is to modify our graph, put line points. So I said now we can do without a line point, which is why I removed the line in the point in this sign X and I left only P. Then I can also put, as I put line point, I said I can also put line color and I can also put LC. And I told you that new plot we have so many line colors. We have red. Red can represent 7, so many of them. So 9 colors 7. You can also put
okay, we should just use the short code LPLC, then maybe we can choose a number 1 or 2. Is that how to put the color?
You can also put title. You can also put so okay. Yes, it work. Yes, just use the short, longer lines in it, so we are able to remove all the lines. And we are seeing this color. Remember, the color 7 means line color 7 means red, while like 6 means blue. So that is what you just plotted now. You can also plot without points and only with lines, which means you can just quickly minimize this thing. Go to your this thing again, then go back to this place, then remove points and put line.
Sallallahu Alaihi Wasallam.
Then go to this one too and do the same. and put line. So you can do it. Are you seeing what's happening? So let's plot another one. So we can plot sine and plot sine x with line points. Remember to always use your Remember to always use your line, your space bar, then comma, we can do x. This star that is in the bottom with your plus is if you want to write raised to power something or anything, you have to put it. So we can do it star times 2 as x2 with then what we are plotting now is 3 graphs. Now I want to plot 3 graphs. One is sine x, the other one is x raised to power 2. Next one is cos x. Are you getting what I'm saying? That is what we are plotting now. So if we click on enter now, you are seeing what we just plotted. So here we have 3 graphs. And this now, remember in your sine x, you have your sine x, then with line points. So meaning that this sine x is this one that have line. Then you have your x raised to power 2 just with line color. Then we have your cos x with line and also with line color, which is this one that goes up like this. So this is it. This just can play around with it. Put your title. Then okay, let's put title. So you see how to also put title. Because we are going to the next stage now. So this now you can also just put. Let me then just put. I just add here, write title. Let's write my. Remember when we are referring to something, you have to put your asterisk, this thing, my favorite data. So this is my title. Yes. Then you can click enter. Zoom. I can zoom this thing now.
عليكم السلام ورحمة الله وبركاته.
ọmọ òtútù yẹn ti ń gbọ́ èmi lára báyìí o láì tí bẹ̀rẹ̀ kankan.
ọba kékeré lẹ fẹ́ sùn àbí.
Please, what can you talk to us? What are you getting? Someone is saying what he's getting is different from ours. What are you getting, please?
I'm getting a kind of a parabola shape.
What do you is your x? Is your x times 2, or is it just 1 times?
I put x star 2. LC7 comma space cos x WLLC6.
And you are getting a different graph.
Yes, I'll try again. Let's continue.
Oh, I don't know. Okay. So I think we are done with the plotting and labeling and modifying. So let's just go to this next stage. This one. plotting from a file. Okay, so we'll have to go back to our Excel sheets. Hope you copied your document, your folder, your this into an Excel sheet. Is it a yes?
Yes.
Not yet, not yet.
Okay, what are you waiting for, Kwan? Please, let me give you some minutes so you can put it on an Excel sheet.
You know, just go ahead. Maybe I'll look for the data later and input it because the hospitals.
Putting it not supposed to be. It's not supposed to be. Not supposed to take all the. It's supposed to be just very simple. Copy this and put there, because I want you people to be doing it as I'm doing, so that you can understand what I'm explaining. To be easier for me to work with you directly, engage you in the whole that's the essence of the workshop, not for us to come and do it later. You are just watching the video. It's not, you're not watching the video, you're doing a practical work. So let's anybody should just please copy this to this. Then next thing you should do, just open your notepad. If everyone should have a notepad now, definitely. So just open your notepad. How do I do this? I don't know how this thing got to enter my screen, but I hope it's not obstructing anything, right? So I just paste this in my oh God. So no, this isn't the data we collected.
It's the same data you copied from that
Yes.
Punjab file.
Yes. It's a whole lot. Should I continue?
Yeah,
Okay, somebody said hold on.
Copy it again from this your Excel file and paste it again. It's misarrangement.
And secondly, Esma, I would like to ask a question, ma'am. These are biostratigraphic data. How did they come about? How did they obtain these data sets?
We got it from Pangea, from someone's work, someone's already published work.
And that person, which instrument, assuming for example, now this data has to be a kind of a petroleum subsurface data. We already know that they use wireline log, and the wireline log is being sent down the hole. The reading from the wireline sonic, all this kind of radioactive measurement. So we already know where the get from, but this kind of it's going to help us to know much about this data. That's why I'm just asked that. How do they go about it?
So what will happen is that you downloaded the data. Me?
Sorry, your voice.
Can't hear you clearly.
Can you hear me now?
A bit.
Yes, yes, yes.
Can you hear me now?
Yes, we can.
Okay. So to answer his question, I think the best thing he would do
Can't hear you again. It's shaking.
is to go and read the person's work. My network is up.
Okay.
Can you hear me
Right
now?
on. Yes, we
So
can.
I think what he should do is when he's free, he can go and download the person's work and get to read it and know which place and which instrument and which method the person used in getting his data. Because we are not interested in the person's method, so we did not read it. What we just did was download data, but that was what was interested. That was what we had interest. So did I answer your question now? We already know some of the methods that they are using to get this data. So what we just need to do is, if you want to know more about how they get the data, how the biostratigraphic data came to how we got the biostratigraphic data, because it's from the PineGL, which is a free space where you can get geological and environmental science data. And it was a biostratigraphy data. How the person got the data is what you can just quickly go and read from the person's paper. I can continue now, right?
Yes, ma'am, you can. I'll do the extensive research. Thank you so much.
So this is the file. I think it's complete now, not fixed the issue. So you just quickly, you can save as. Is in a text file. I don't know if someone can be smart enough to tell me why I'm not seeing any other file apart from the text file. So simple thing is that if you want to save this on a, if you want to save it on a new on a CVS file, you have to make sure that all this text in it, that the only thing you are seeing is numbers. So when you have to go back to this your you have to go back to this place and eliminate this so that you only have numbers. So that was what I was trying to do then. I think we should just copy out. Oh, shit. So we can just simply go to this place and start from here. Copy this instead. Then so we only have only numbers. Okay. So in this number we have now, and I want you to know something. What you need to know is that in new plot, when you interpret this as y as this as z, and this as anything that concerns it. So or else you use your hand to change it and tell him to do this, do range 2:1 as x axis, x and y axis, or do range 3:1 that you want to call your x or your y. But if you not direct it on what to do, it's automatically going to pick the first one as x and the second one as y axis. So you have to save this as a CVS file. Save. No. Okay, let's open a folder. New dot data.
Miss Roots, please, I want to ask, what are you trying to do right now? I'm confused.
I'm trying to save this data now. Need to save this data because we need to start importing this data in our new plots.
Okay.
That is what we are trying to do. So when we go to our new plots, so you can see what I'm doing now. There's a changes you are seeing, right? This is what we have done before that is showing the ones that we're able to save that is showing. But nevertheless, what we're interested in is importing data from a file. So just go here, go to change directory. So locate the place the data is. Data is in our, yeah, this is it. So put it here. So this is the directory of where we are going to be working on. So here we can do anything, direct is plot X to this, plot this to this, plot this to this. So please, can you talk to me? Let me know if we are in the same page. Are we in the same page?
Yes, ma'am.
Yes, ma'am. I'm trying to import data, but the folder is not showing anything.
You're trying to do what?
I'm trying to import the file into new plot, but the folder is empty.
You're trying to import this, you're trying to plot already.
Import.
Or you're trying to just put. Are you importing it? First of all, it's supposed to change your directory. Have you done this change directory that we just did?
We have not imported the data first. Change the directory.
Okay.
To
So
the
please, am I going to
directory.
change
Yes,
directory?
we have not gotten to the importing of data. Change directory first.
Okay, change directory. Okay. So where should I change it to?
Please just tell us how to change it again, please.
Okay, so what I did was I went to my file, I went to change directory. I went to the place I saved this my new plots in, which was in my OneDrive under my desktop. You see what the folder I called it new.data, and I clicked on it. Then I make it okay. Then it has entered here. I see I've gone to put another thing.
Okay, I've been able to do that. Thank you.
Sorry, please, I didn't hear it. I did not hear you clearly. Can you come again?
So we are here now. And now do plots.
Sorry, please, can you come again with this change?
Using 1:2. Remember, open our. What should I come again for? Is it the plots or the change directory? Which one?
The change directory.
You go to your file. Are you with me? Can you hear me? Answer me. Let me know if I should continue now.
Yes, I'm with you.
Go to your file. Go to change direct. You can see my screen.
Yes.
Click it. Then locate where you say. Hope you open the folder for your notepad, right? You name this.
Yes.
So go to where that place that folder you open and name. Then click on it. My own is new data. So just put OK and it will come. That is all. Okay. Can we go ahead now? I'm on this workshop. We have so many this thing. Okay, we can do plots. This our new.
Sorry, we can't hear you clearly.
Just be watching me. If you can't hear me, just be seeing what I'm doing. I'm doing the same thing. Okay. So what I'm doing now, I'm trying to tell the new plot to plot this my data now. The place my this data is using 1:2. Remember, I said in that place we have more than one data. That if you don't direct new plot what to do, it will automatically call the first line the x-axis and the second one the y-axis. But you can decide to use your hand and tell what to do. And what you used to do it is this 1:2 or 2:3 command. So that which is what we are doing now. So we can add with line points, then y. I think the inconsistency of this particular. Please, can you go back to your Excel sheet?
I guess I think it's GNU here, but you save it as GNU.data.
I don't know why some of these things are not showing.
It's showing, it's just the linear arrangement. It's not well lapped. It's not, it's there.
Or let's just use this order of my folder and just work. So later you can easily navigate on yourself. Let me just use this so I will do a bit faster. I'm getting a bit exhausted too. Check. Please hold on a bit for me. I'm coming. I think we can use this folder, this data instead. 9. This is for set log. Okay. Will this thing not stress us this day in Jesus' name?
And Miss Ruth, I feel you should go back to your Excel and then copy it again. Start copying it from that 2 point something.
Yeah, that was what I did last time now.
Try again.
That was what I did last time. Let me open a new one. Do you want to change this? No, don't say. Yeah, I see the same thing.
I got is the renaming.
I think
Is
it's
it
just the arrangement.
Yeah.
If not, it's the arrangement. If not, everything is there. Like
because
the
we
way it's
need
arranged
to
itself.
make
In my
sure
own
that
system,
this
arranged well.
your own system is arranged well. So that
No,
means
it's well arranged.
I don't know what's wrong.
No,
That's what I'm looking.
The other time you save it as new, then you were typing new dot data.
Because this is not, the new plot is not finding this as any data. It's finding it as empty data because we can't save, we haven't been able to save it as a CVS file, which is what we are supposed to do. Please, the person that is seeing a full data, can you save your own as CVS file? CSV, sorry, I said CVS. CSV. David.
Yes.
Are you able to save your own as CSV file?
No. I just saved it like that as text.
Yeah, it cannot. The thing is that new plot does not understand text file. So we need to work on this data. You can see the data where we go collect no good. We need to work on this data. So let me know if I have a data in my system that we can use. Then later we can be able to start fixing this whole thing, or we can even generate data ourselves.
Okay.
You can do 1, 2, 3, 4, 5, 6, 7, 8, 9. I can do Then we can do that's square of this. Then we can do 1, 4, 4, no, 1, 4, 9, 16, 25, 36.
You know,
36.
if you copy this and paste it in Notepad, you can still save it as CDF file.
Why?
Because it's literally the same thing.
Let me check if this can interpret this directly without going to Notepad. I think it will. I think it will. Okay, let's go back to our new plot again. But why this new plot is always going out is what I don't even understand. So we can go to our directly now, change, go to desktop. Make a folder. Why is this stressing us? I think first of all, I need to save this. So Please, give me some minutes. Let me fix this data stuff, please.
No problem.
Hello, can you hear me?
Yeah, we can hear you.
I seriously don't know why
We can
we
hear
can't
you.
use. Yes, I don't know why we cannot use this data. It's showing us that it's empty data in it. I don't know. I'm trying to figure out the reason because we are supposed to be able to save. We're supposed to be able to save the notepad, the information as. I don't know why it's still showing us. So what I suggest now is that we should just go ahead. I should go ahead and explain everything to you. Then the only thing that will be remaining is probably how to put it, because I can teach you everything I want to teach you without importing the data. So the difference is that you don't have a real life data that you're working with. So I can continue my teaching so that we don't waste so much time, because this is already far time spent. Then after, I can do a video and send to you how I fixed the data in TSV and we're able to plot it. Do you agree? So I'll continue.
Yeah, it's a lovely idea.
Please,
Yes, ma'am. Do you have a properly good data which can just use as a sample?
Perfect.
Hello, ma'am.
Yes, I can hear you. Can you talk?
Yes, ma'am. I said, do you have a previous data which you've worked on that you can share to us? We can use that as a sample.
The data I have now, the data I have, paleontology data I have here is not processed. It has so much of letters in it. So before we can use the data, we have to first of all process it, like remove some things in it, which will take more time. So I suggest I will just continue and teach everything, how the other things we are supposed to learn. Then later I will still use this our data and figure out why it's showing us empty, because the data we have already saved it as CVS. But the problem is that when we put it on the new plots, it's showing that the data is empty. Okay. So I need to find out the reason why it's showing that. So let me just continue the whole process without increasing of data. Do you get?
Okay, ma'am.
Thank you. So we are skipping this data whole stress and continue.
You can write them, ma'am.
Okay, because we are supposed to see the new plot, settle up, then already fast. So let's just start with our plot sign X sine x. So we plot sine x. You can now say, you can even, the next thing you can say is, we're here. So the next thing you can say is then plus sine x, comma, or you can say with line points and width of 2 and line color 7 and comma, we have cos x with line point width of 6, 9, 6 is too much, 3 line color 6, then you plot. So this is what we just did. Oh, you wait, no, you're supposed to recognize it. Plot it proper. So we can set next one now. We can also use our, this instead of writing again, you can now put set x label to be 9, yeah, to be maybe v, then set y label to be sine x.
I'm not doing. Oh, I got it.
Okay, do you know why it shows this unrecognized option? Because there is a space between the y and the label, which is not supposed to be. Okay, so now you can say we plot, then you have this, you can see your v, you can see your this x. So we have done all this whole thing. The next thing we are going to do, let's go back to our PowerPoint to see the next step we are supposed to do. We have skipped this plotting with data. Okay, so what we are going to do is now these polar plots, parametric plots, plotting of histograph, how to save a image, and the rest. Okay.
Okay.
Yes. So we have skipped this plotting of files. Okay. But the place I am, are you able to follow me to that place? Like, are you?
Yes, ma'am.
Yes, ma'am.
Ma'am.
Thank you. So you can maybe, as I'm trying to get the histograph, then you can add, this work we are doing now. The one interesting thing about this new plot is that you are the one that is telling it anything you want. So you can even tell it now to maybe add some other things for you, like you can add more line. It was one we did before. Oh, okay. So for you to export it as an image, this is what you do. Just quickly go to this place. You can export it as PDF file, export it as SV, export it as image. Just here is where you're going to get your export as image. So that means you have settled this number, last one. So what we are doing now is making a histogram. So we can easily run through these two things and go and go and so for you to plot your histograph, you can do it directly, and you can also decide to. This histograph needs data. Check. This histograph needs data. What I'm going to do about this data thing now? Okay, let's do how to put ranges. How to put ranges. So let's do how to put ranges. Plots. Course. I hope you are seeing what I'm doing. You know the meaning of all these things. Point size, line points, point type, all these things. That is what I'm writing. Point color 9. Okay. Then what again? I'm going to put line width 2, line width 2. What again can we add? Just trying to make our work look neat. So this is what I just did now. So next thing you can do to set range, you can do set. You can set your range. Set range. X range. X range. Set your X range to be. Now, when you are setting range, what you are going to put, because you are not putting anything alphabetical. What you are putting, remember when you are doing your X here is alphabet. You are using this normal bracket. But when you are doing the one that is not alphabetical, you're not using normal bracket. You're using the square one. So you have to be conscious of it. Right. So this one, we can do -4, -4, -4.0. Then we can do this. We can do pi. Just getting inspiration of what to do. 4.0. Yeah. Pi. Then we can close our thing. Then this is this range. Then we'll set the other range for the y-axis. It's y range. Then remember your block. You can do -1, maybe -1, or maybe -2.0 to 1.0. okay, or to positive 2.0, something like this, 2.0. Then your this, then you can now plot your this, plot this. So if you look at this thing now, you see that your y-axis is between -2 and -2 and +2, and this one too is between 4 to 5 range. 4 minus 4 pi to minus +4 pi. So this is just what we just did now. So the next thing now to do is you can do reset 9. Okay. Remember to always come back here. You can do reset. Then, and you can do so you see when you do clear, nothing is in your database, nothing is in your plot again. That means you want to do another new thing. Then you can do this again, maybe change some things. You can, I'm thinking of any other parameter you want to do when you are plotting that you have not done. Now let's add more order. Then we have plot of course. We can add 3 plots and see how it's going to look like, or 4 plots and see how it's going to look like. So when we are adding this, remember you're putting your comma. Then you can also putting your comma. Then you now do sign and do, okay, let's do, instead of sign, let's do x asterisk raised to power of 4. Maybe that will give us something different. Then you can do with, remember your spacing with line points, point type 7 or point type 6, point size 2, line color 6, line color 6, and what again? Then you can do another comma. So we can have 3. Then we can now do cos. Cos x with line points, point type 4, point size 2, line color 5, line width 3. We did not put line width in this one, in the second one. So let's put line width 5. So this, okay, this is, I made a mistake. This is not I, this is L, line width, line width. Is there another thing we're supposed to put? See our graph. So you can see we have these 3 things here. This, but I'm looking for the third one. Where is it? So you can hide anywhere you click on, you hide it. So when I click on this cos x, I've hide it. So if I click on this one will disappear. If I click on it again, it appears. If I click on it again, it appears. So if I click on it again, it appears. So this is just how to do the whole plotting of the graph. So the histograph needs a data. Histograph needs a data. I don't really know how we're going to do it now, but I will just have to teach you how to do a script, then and import the script in your new plot. And the script is done with your notepad. So just go to your notepad now if you are listening to me. Are you with me?
Yes, ma.
Yes, ma'am, we are with you.
Yes, ma'am.
Okay, so just go to your notepad. So you can write your script here and import it. And import it in new plot. So you can do writing a script, maybe because when you want to do your histograph, the difference with what I'm going to show is that there is no data that will show the histograph that you are plotting, but every other thing is there. Every other thing that you are going to plot is there. So, which is your writing, or you can also write this indirectly to your new plot, but it's more safer to write it here because in your new plot, if you have your data, you can be displaying some of the data in your new plot, then be implementing the thing here, because for you to do a histograph, you have to know the maximum and the minimum, the ranges of it, the width of it, and which you need to have a overview of your data and know how it look like before you can do that. So I think we should just do a multiple. Let's plot a multiple graph, like plotting one graph in one place.
Sorry, please
like
come again. We're
graphs.
not hearing
you. Can you hear me now? Let's plot a multiple graph, like plotting one graph, 4 graphs in one place, 4 different graphs in one place. Before we can do the scripting for this thing. Do you hear me?
Yes.
Yes, ma'am.
So I should continue, right?
Yes.
Thank you. So let's plot a multiple graph now. I think that's the next thing we should do before I explain how to do the scripting for the. So you already know how to do sin X, right? See the blunder I made. You have to do plot sin X. This is your normal sin X now. So you can do plot sin X. This is it. If you want to plot in this same place now, what we want to do now is plot 4 graphs, different graphs in this same place. We have cos X in this same place, have maybe tan X in this same place. That is the multiple graph in one place. You have seen some papers, you will see one picture, you have different types of graph, one going up. So this is what we are trying to do here with it. So now we have this thing. Now we can let me just minimize this. So achieving this, what we'll just do is we just have to do another comma and add another thing. So let's go back to our script. So we have this with line already. So we can now put maybe set origin. Yeah, as remember when you're putting (0.5, and 0). So essence why I'm putting this so that you will know, you'll be seeing the difference between the one you have plotted and the next one you're going to plot. So then you can now do plot X asterisk 2 with line, then you can do set origin. You can do 0.5, 0.5. Then I think we made a mistake. We'll have to, first of all, before we have to call the multiple graph first so that we can be able to use multiple graph. So let's go back. So you have to first of all call multiple graph first, because if you did not call the command for multiple graph, this plot you're plotting will also still be in separate graphs. So that is the essence. We need to first of all, our new plot, we have to set multiple graph. How to set multiplots. I call it multiplot. Good address. Oh, this is crazy. Multiplot. Okay. Now I've set the multiplots. Then the next thing, you can even go back again to start doing all this thing. Maybe set size. 0.5 is to 9. 0.5 comma 1. Then set multiple 0.5 comma 1. Set graph. That's a mistake. Undefined. I wrote O instead of 0. I think I'm getting tired. So it's supposed to 0.1 then. Okay, good. So you have this now. Then you can do set origin. Set origin as 0, 0. Then you can now plot your sine x. Then you can now set your origin again. Set origin. For this is for the next one you're doing now. For the next graph you want to show, we are doing different types of graph showing in one place. For the next graph you're going to do now is the one you're setting a new origin for. The one we did is 0, 0. The next one is, let's do for 0.5 comma 0, 0.5 and 0. We have done 0.5 and 0. Then what's this? Okay. I've seen a mistake. You have to be this particular this thing is very, very conscious with just because of the spelling. It's very case conscious, so it will just not work. So we can now plot all these things we have done. Plots supposed to show me what I'm doing. Function to plot except plots. They are supposed to plot sine what now? Now we are plotting plot sine x. Then we'll set another origin again. Set origin. Set origin, or we can do 0.5 comma 0.5. So then we can plot another one to be x asterisk 2 maybe with lines. Why are we not seeing all this? All this our plotting. Nine. I think this is the one we were plot before, right? We plot. Let me see. Your sign X is different. Why? Can you talk, Duni?
No, I've solved it. It's better now. Same with yours now.
I don't know why we're supposed to be seeing what we are plotting. No. Okay. Let's unset this multiplots. Unset multiplots. Okay, look at what we are plotting. Look at what we are plotting since that we are looking for. So if I click on grid, so why is this grid? It's just trying to get.
Hello.
Yeah.
Hello, my name is Austin.
Yes.
I think where the error is coming from, check the second, the 1, 2, 3, 4, 5, 6, 7. Check the second column. There's one place you are supposed to spell origin. You spell.
Yeah, we did. We did it again. We reviewed it again.
Okay.
We set another origin very well.
That error is still showing. Go back to multiplot. Set from set size 0.51. Set origin 00 years. Now set sin X. Now set origin. Go down again. O arrow is supposed to be O arrow IGIN. Go back. Yeah. No, go back.
Yes.
No, yes. Go back. Yes. Correct
we had an error here.
Okay, so correct that one first.
We corrected it here. We have corrected it already before we could plot to this extent. So this error has been solved already. I think I over-zoomed this whole thing. That is why, because the first time we reported it, it showed all the 4 plots. So I think we should just
reduce. You want to reduce the size again? Let's follow the syntax. I think we have an error with the syntax. What's the error showing?
It's not, for me, the error has been solved because the unrecognized, the place they have unrecognized options, see help. We solved it, yes, see help sets. So
yes.
we solved it here. We solved it here where we put this. I recognize the spelling and I corrected it here. Then this place again will have the function because we didn't put a function to be plot, which we fixed here. So as at the time we got to this plot, we are able to already this onset multiple plot. It appeared that we have the multiple plots we are trying to do. So what I suggest is maybe we can quit and do the multiple plot again. Are we all together?
Okay. Go ahead. Let's see.
So here, I think that would be the best for us. The best for us is just to quit and start the multiple plots all over again. So first of all, we'll set multiple plots. Multi-plots, I mean to say not multiple. Because as I'm saying multiple now, if we know that I'll start typing multiple. Multi-plots. So we'll set multi-plots, then it's coming. Then next thing we'll do is to start setting the sizes. We have to set what's happening. Set multi-plots. Set. .5, 0.5. Then next thing to do is to set origin. Set origin. Hope this pen is correct. 0, 0. Okay. Then we can now plot our sign X with line. Then this one has come. Then the next thing we'll do is to set another origin. Set. Need to come here. Yeah, set origin and do 0.5, 0, 0. Okay, and do 0.5 and 0. I think that is good. Then we'll plot x raised to power 2 with line. Then why is the first one not showing? Okay, let me continue and finish it first. Okay. Finish it first. Then the next thing we'll do is to set another origin, maybe with 0.5, 0.5. Then we can plot cos X with line. Something is wrong with this. all this supposed to be showing in one piece. New plot is giving me wahala. Start from gene 0, 9, 0.5. Then plots done x. So where is the issue from? Let me see. It's obvious that it's all of them is not showing. I don't want to believe that this is also because of data. I don't want to believe that. I'm supposed to have I don't want to believe that this is working because it's not data. Okay. Sorry, can you hold on a bit? I have a So what do you guys think? Should we continue tomorrow? But I think tomorrow we should not do this new plot again. Maybe the new plots, the remaining ones should be in the video. Don't have data. I don't want to believe that. That is why, because normally we're supposed to be seeing the 3 plots, and the 3 plots are plotting separately, and which is not what it's supposed to be. So, can someone talk, please?
No.
Huh?
Ma, you said the remainder of the new plot will be done and then sent to us video, yeah?
Yes, because this issue we are having, all thinking is because of our lack of data. That is why we are having it. So, if we can fix the data, we can have, because what is remaining to understand this new plot is the histograph, which cannot be done with data, and this multi-plot again.
Okay, ma.
Video, then send it to you. So let's put on the said log, and everyone should just go. What do you think? Or should we call it a day? Because tomorrow we'll still have.
And we can't hear you.
Is that tomorrow? What were you saying about tomorrow? Miss Roots?
Can you hear me?
Yes, we
yeah,
can
I
now.
hear you now.
So as I'm saying, should we quickly run the set log and everyone goes, or we should just still we should just go like that? What do you think? Because the set log is easy to I think it's more easy to understand. This whole script writing may be a little bit difficult for us.
I think a lot of persons have gone offline because
We
of
do
the
the set log.
Yeah, I feel we should call it a day and then kick off with Sedlock tomorrow.
Because a lot of persons have gone offline because of the time, and I think the network is bad.
Yeah, so tomorrow is not so bad.
So that means tomorrow we should do it in the morning, because if this is taking us a lot of time like this, that means it's still going to happen tomorrow. So tomorrow, we can do the Zoom in the morning and have a lot of time, because anything evening will also delay us this way. What do you think?
Yeah. Yes, ma, that's perfect. What time in the morning?
For
me, anything from 10.
No, tomorrow morning, it's not something that people actually like plan for us. We did not send the message like on time, so I don't think people might be available for tomorrow morning. Plus it's weekend. So I think we can still stick to 9.
People are always at home on weekend.
People also have events during weekends as well.
I don't know, but I think
we can.
Tomorrow in the morning will be better for me. In the morning tomorrow will be better, because we will have a lot of time to settle things we're going to settle and any other thing we do. So, but I will fix this new plot.
I think we can discuss on the WhatsApp group and then
we'll get back to you
out from there.
Okay, I think that will be perfect. So we can close this for today. Then tomorrow we'll continue. Let me fix this new plot, then send the video quickly before I go to bed this night.
All right. Thank you very much.
Thank you very much, ma'am.
Thank you. Good night, everyone.
Yeah, good night.
Good night. Good night to you.
All right, good night.
Hello, President. Prince. Hello, Prince. Are you still there?